Welcome back. Let's talk about the law of conservation of mass. This law was given by Lavoisier in 1789. The law states that matter can neither be created nor be destroyed by any means, although it can be transferred from one form to another. From this particular statement, three important points emerge. The first point is the total mass of reactants must be equal to the total mass of products in a closed system. Now, as atoms does not appear or disappear by any means, clearly atoms only rearrange their positions into a new shape. And the third point is atoms of elements on reactant and product side must be same. That is, the equation should be balanced. This law helps us to find the amount of reactants consumed and products produced in a chemical reaction or in a process. This can be illustrated as. So we have the first illustration that says, for the following reaction, 4.2 grams of sodium bicarbonate upon reaction with 10 grams of hydrochloric acid, it produces 12 grams of residue and 2.2 grams of carbon dioxide. Then show that the reaction obeys the law of conservation of mass. Since we know, as per law of conservation of mass, the total mass of reactants must be equal to the total mass of products formed. Therefore, we simply have to add up the masses on the reactant side and the masses on the product side. Therefore, upon combining the masses on the reactant side, we found the total mass of reactants equal to 14.2 grams and that of products is also 14.2 grams. As the mass of products is equal to the mass of reactants, clearly the reaction obeys the law of conservation of mass. In the same way, we have the next illustration that says if 100 grams of mercuric oxide is heated to produce 92.6 grams of mercury and X grams of oxygen, then find X if the reaction obeys the law of conservation of mass. Now, in this case, as the process or the reaction obeys law of conservation of mass, clearly the total mass of mercuric oxide must be equal to the total mass of mercury and that of oxygen. While putting the masses of mercuric oxide and that of mercury, we got 100 equal to 92.6 plus X, and that boils down to X equal to 7.4 grams. Therefore, the mass of oxygen produced is actually 7.4 grams. Similarly, we have the next illustration that tells us if 1.5 grams of ethane on combustion gives 2.7 grams of water and 4.4 grams of carbon dioxide, then show that the reaction obeys the law of conservation of mass. In this case, ethane molecule undergoes combustion reaction in the presence of oxygen and it produces water and carbon dioxide. Since we are given with 1.5 grams of ethane, 2.7 grams of water and 4.4 grams of carbon dioxide, but we are not given with the mass of oxygen that reacts with ethane molecule. So before showing that the reaction obeys the law of conservation of mass, we need to calculate the mass of oxygen that combines with 1.5 grams of ethane molecule. For this particular purpose, we need to balance the above chemical equation. Now, while we try to balance the equation, the stoichiometric coefficients include 2 for ethane, 7 for oxygen, 6 for water, and 4 for carbon dioxide. Now, the number of moles of ethane will be equal to 1.5 by 30 because 30 is the molar mass of ethane molecule, and that boils down to 0.05 moles. Now, from the given chemical equation, 2 moles of ethane combines with 7 moles of oxygen. Therefore, This would imply that 0.05 moles of ethane will therefore combine with 7 by 2 into 0.05 moles of oxygen. And that upon solving gives you 0.175 moles of oxygen. Now we got to know the moles of oxygen that actually combine with 1.5 grams of ethane. From this, the mass of oxygen can be calculated as mass by molar mass will be equal to number of moles of oxygen. Mass of oxygen will therefore be equal to 0.175 multiplied 32, because 32 is the molar mass of oxygen, and that boils down to 5.6 grams. Therefore, the mass of oxygen that combines with 1.5 grams of ethane is actually 5.6 grams. Now let's get back to the question. While we add up the total mass on the reactant side, and that comes out to be 7.1 grams, in the same way while adding up the total mass on the product side, it also gives us 7.1 grams. As the mass of reactants is equal to the mass of products, clearly the reaction obeys the law of conservation of mass. Point to note is, law of conservation of mass is obeyed in almost all cases except in FAV. That includes those cases where the mass energy interconversion takes place, and that usually occurs in nuclear reactions. And it is also disobeyed in case of open systems. I hope you understand this. If you like my videos, please do not hesitate to share and subscribe. Thank you.